When connecting a generator to a transfer switch, proper wire sizing is crucial for safety and performance. Firstly, let's address the generator to transfer switch power leads. The minimum wire size you should consider is number 6 AWG copper or 300 mcm aluminum. The maximum wire size should be 250 mcm copper or 1000 mcm aluminum. A recommended wire range to consider is number 6 to number 1 AWG copper or 300 to 500 mcm aluminum. Secondly, let's look at the generator to transfer switch start circuit wires. The wire size for this circuit should be number 18 AWG copper. The maximum length for this start circuit is 480 feet. It's important to consider several additional factors. Firstly, calculate the voltage drop over the length of the wire to ensure it does not exceed 5% under load. Secondly, the wires should be installed in a conduit or other approved enclosure to protect them from damage. Thirdly, make sure the total length of the wires, including the conduit, does not exceed the maximum recommended by the manufacturer. Fourthly, properly ground the generator and transfer switch according to the National Electrical Code or NEC requirements. Fifthly, use stranded THHN or XHHW wire for generator installations. Based on manufacturer recommendations, the following wire sizes are recommended. For generator to transfer switch power leads, use 1/0 AWG copper or 4/0 AWG aluminum. For generator to transfer switch start circuit wires, use number 18 AWG copper. Remember to consult the NEC code book when it arrives to verify the requirements and ensure compliance with all applicable codes and standards. Selecting the appropriate wire size is critical for the safe and efficient operation of your generator and transfer switch system. Factors influencing the selection of the right wire size include the ampacity of the conductors, the voltage drop across the wire length, and the type of insulation used. Ampacity refers to the current carrying capacity of a conductor. The NEC provides tables, such as Table 310.15b16, that list the allowable ampacities of insulated conductors rated for not more than 600 volts, based on their size and insulation type. For example, a number 6 AWG copper conductor with THHN insulation has a higher ampacity than a number 6 AWG copper conductor with TW insulation. It's crucial to select a wire size with an ampacity that meets or exceeds the calculated load current for the generator circuit. Voltage drop occurs as electrical current flows through a conductor. The longer the conductor and the higher the current, the greater the voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use formulas or online calculators that take into account the wire size, conductor material, current, and length of the circuit. Insulation type also affects the allowable ampacity and suitability of a conductor for specific applications. THHN and XHHW are commonly used insulation types for generator installations due to their high temperature ratings and resistance to moisture and chemicals. These insulation types are suitable for both wet and dry locations, making them versatile for various installation environments. In addition to wire size and insulation type, consider the installation method when selecting conductors. The NEC specifies different ampacity correction factors for conductors installed in raceways, cable trays, or direct burial applications. These correction factors account for the effects of ambient temperature and conductor bundling, which can reduce the ampacity of the conductors. Grounding is another critical aspect of generator installations. The NEC requires that generators and transfer switches be properly grounded to provide a safe path for fault current. Grounding helps to prevent electrical shock hazards and minimize equipment damage in the event of a ground fault. Use a grounding electrode conductor of the appropriate size and material, as specified in NEC Table 250.66, to connect the generator and transfer switch to a grounding electrode system. The grounding electrode system typically consists of ground rods, ground plates, or the metal frame of the building. Conduits or other approved enclosures are essential for protecting conductors from physical damage, moisture, and environmental factors. The NEC specifies the types of raceways and enclosures that are permitted for different applications. Metal conduits, such as ENT and rigid metal conduit, provide excellent mechanical protection and can also serve as equipment grounding conductors. Non-metallic conduits, such as PVC, are lightweight and corrosion resistant but require a separate equipment grounding conductor. When installing conductors and conduits, ensure that the conduit fill does not exceed the maximum permissive by the NEC. Overfilling conduits can make it difficult to pull conductors and can also increase the risk of conductor damage. Use a lubricant to facilitate the pulling of conductors through long conduit runs. Furthermore, when connecting conductors to terminals, use the appropriate connectors and torque them to the manufacturer's specifications. Loose or improperly torqued connections can cause overheating and electrical failures. Use a calibrated torque wrench to ensure that connections are properly tightened. Labeling is another important aspect of generator installations. Clearly label all conductors, raceways, and enclosures to identify their purpose and voltage. This helps to prevent confusion and makes it easier to troubleshoot electrical problems in the future. Use durable labels that are resistant to moisture, chemicals, and UV radiation. Regular maintenance is essential for ensuring the continued safe and reliable operation of your generator and transfer switch system. Inspect the wiring, connections, and grounding system periodically for signs of damage or deterioration. Tighten any loose connections and replace any damaged components. Furthermore, test the generator and transfer switch regularly to verify that they are functioning properly. Perform load tests to ensure that the generator can handle the expected load demand. Keep accurate records of all maintenance and testing activities. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing the installation yourself. An experienced electrician can ensure that the installation is done safely and in accordance with all applicable codes and standards. Furthermore, the NEC is updated every 3 years, so it's important to stay current with the latest requirements. Obtain a copy of the latest edition of the NEC and review it carefully before starting any electrical work. Consider attending electrical training courses or seminars to enhance your knowledge and skills. Furthermore, familiarize yourself with local electrical codes and regulations, as they may differ from the NEC in some areas. Contact your local building department or electrical inspector for more information. By following these guidelines and consulting with qualified professionals, you can ensure that your generator and transfer switch system is installed safely and correctly, providing reliable backup power when you need it most. Always prioritize safety and adhere to all applicable codes and standards to protect yourself and others from electrical hazards. Remember that this information is for general guidance only and should not be considered a substitute for professional electrical advice. Consult with a qualified electrician or electrical engineer for specific recommendations based on your particular application and local codes. Staying informed, following best practices, and seeking expert guidance are essential for ensuring the safe and reliable operation of your generator and transfer switch system. Always remember that working with electricity can be dangerous, and it's crucial to prioritize safety at all times. Take the necessary precautions to protect yourself and others from electrical hazards. By following these guidelines, you can ensure that your generator and transfer switch system is installed safely and correctly, providing reliable backup power when you need it most. This information is intended for general guidance only and should not be considered a substitute for professional electrical advice. Consult with a qualified electrician or electrical engineer for specific recommendations based on your particular application and local codes.